So in this video we will discuss the extrusion process. Okay, so extrusion is a manufacturing process which is generally used to produce products such as long bars, angle sections, rods, channels, circular and non-circular tubes. So this process is generally used to produce bars, products such as bars, rods, angle sections, channels, circular or non-circular circular tubes like this. And as well as, so these are the products which are generally are of larger lengths. Okay, larger length. And this process can also be used to produce small size products, just like the toothpaste tubes, just like the toothpaste tubes, the shell cases of the gun ammunition, okay, like this. So this process can equally be used to produce large size products such as the bars, angle sections, channels, tubes, and small size objects just like the toothpaste and the shell cases of the ammunition. Okay, in this process in general we use the compressive forces to produce the product. So this is the first important point. We use the compressed forces, and the desired shape of the product is obtained by using a combination of die and punch or ram. The main equipment of the extrusion process is the die and a ram along with a, a container. So we will discuss these things as we proceed with the lecture. We have a classification of extrusion process, types of extrusion process, as the direct extrusion process. So the first type is the direct extrusion process, another type is the indirect extrusion process, and the fourth type is the hydrostatic extrusion process. So the first extrusion process is the direct extrusion, second is indirect extrusion, third is impact extrusion, and fourth is the hydrostatic extrusion. The last one, the fourth one, is the hydrostatic extrusion. So these are the four types of extrusion processes: direct, indirect, impact, and the hydrostatic. So let us begin with the first extrusion process, which is the direct extrusion process. This diagram depicts the cut section view of the direct extrusion process. As it is seen from this diagram, the main equipments of the direct extrusion process is the container. The first one is the container. This is the container. Then we have a ram to press the material, which is termed here as the pressing stand. Then we have the ram. Okay, then we have a particular shaped die, the die bagger to support it, and the raw material in the form of a billet. So this is the container. This red colored one is the desired die of the desired shape. This is the die bagger, and this is the initial workpiece stock, which is the in the form of a billet, and this is the ram which will be used to compress it. Okay, so how it works? The workpiece is placed inside the container, which is closed. Okay, then it will be forced with the help of this ram, and this material has only one cavity to escape out, which is the shape of the die, and through which it comes out as the final product, as the extruded product. So this is the direct extrusion process. Here if we see that the direction of the application of the force on the ram or on the workpiece is same as the direction of the extruded product. Both of these are in the same direction. That is why it is termed as the direct extrusion process. Okay, so if I draw its front projection from seeing from it. So it consists of a container. I am making the view, one of the view of the setup, this three-dimensional setup. You can draw this view in your exam to explain the direct extrusion method. So this is the cylinder, this is the container, this is the container. Okay, this is the ram. Here we have the ram, here we have the ram, this is the ram. Okay, this is the ram, this is the ram. Let me fill it. In between this ram and the container we have the workpiece. We have the workpiece in place, which is in the form of a billet. That this is the size of the billet which is in the container. So this is the billet. Okay, this is the billet, and at the one end of the container we have the die of the desired shape. Die of the desired shape. Here we have the die. Here we have the die of the desired shape. So this is the die which is attached at one end of the container. One end of the container, and it is being supported with the help of a die backer. To back it, to support it, a die backer is installed at one of the ends. So this is the construction of the direct extrusion method. So this is the container, this is the ram, this is the initial workpiece material, billet, this is the die, and this is the die backer. Die backer. So with the ram we can also use a pressing plate here, which will be in contact with the workpiece. So that this area depicts the pressing plate. Okay, so this is the setup. This is the setup. Okay, so what happens? That when we apply the forces on it, when we apply the forces on the ram, so these forces will get transferred to the billet material. When we apply the forces on this ram, and through the pressing plate, the forces will get transferred to the billet, which will make it to move in this direction. The billet starts to slide against the cylinder wall, container walls in this direction, and firstly the billet will deform in order to fill this space, Okay, so when we will apply the forces, the forces through this ram, what happens? This billet starts to slide and will fill this and will occupy the spaces left in the container, will occupy the spaces left in the container by sliding against the container walls, Okay, and then further movement of the ram in the forward direction, as shown in this diagram, with the further movement of the ram in the forward direction. Now this billet has only this space, this cavity, the cavity which is in the die, so this is the only space left with the billet to escape out, so through which the billet gets deformed and comes out of this die opening. So whatever be the shape of the die, that exact shape will be produced on the extruded product. So this is the extruded product. Okay, so and if we closely look, that we are applying the forces in this direction, in this direction, and in the same direction we are getting the extruded product. So when this is the case, that type of extrusion process is called as the direct extrusion, is termed as the direct extrusion. Okay, now here, since billet slides against the cylinder walls, so there is an issue of friction. There is an issue of friction, due to which we need to apply extra forces, large forces, to overcome this friction between the cylinder walls and the billet. Of course, we use lubrications to reduce the friction between the billet and the cylinder walls. Okay, now this problem can also be minimized by using the second type of extrusion process, which is the indirect extrusion, process. So here, if we could see closely that in case of the indirect extrusion process, the first view will represent that the direction of the application of the force on the piston or the pressing stem is this, if we could see it closely, and the direction of the coming out of the extruded product is this. So these both are in opposite direction. That is why it is termed as the indirect extrusion process. So in indirect extrusion process, the direction of application of force to move the ram is opposite as that of extruded product. We can see it here as well. So for this to achieve, we need to have a specially designed ram or the tool stem. We need to make an opening in the ram through which the extruded product comes out. So if we could draw the front projection of the setup, so this is the cylinder container, and now this side is completely closed. This side is completely backed with the help of a backing disc. Okay, now this is filled with the help of the raw material. The container is loaded with the help of the billet raw material. Now this is all loaded. Okay, this is all loaded with the help of the billet. Let me fill it. And then a specially designed tool stem or ram is placed at its other end, and that specially designed tool or the ram has the slot to fix the die in it. Okay, to fix the die in it. So this is the ram here. This is the ram surface. Which has a slot in it. And at the end of it we have the die. At one end of it we have the die of the desired shape. So this is the die fixed here. Now as we will apply the forces through this ram, let me first name the different parts. So this is the backing disc, which is located here. This is the billet. These are the rams, specially designed rams which has a slot in it, and this is the die. So as we apply the forces in this region, what happens that as the forces are applied, so this die and this ram assembly moves in this direction, and because of that, when this die makes a contact with the billet, and this compressive force which is applied by the rams will deform this billet against it, and the only space left, the shape of the die would be like this. Let me just revise it. Shape of the die will be like, we will apply forces through ram on it. The only space left for the billet to move is the space provided by this die only. So the billet makes the contact with the die, and then after further compressing it with the help of the ram force, the only space left for the billet to come out of this die is in this direction, okay. So the direction of movement of the extruded product is this. So they both are in opposite direction. That is why we name it as the indirect extrusion. So here if we closely look, that there is no sliding of the billet with respect to the container walls, as it was happening in the direct extrusion case. So there will be very less friction. So the problem of friction which was in direct extrusion process is eliminated here. So we need to have the lower forces to deform the or to extrude the final product as compared to the direct extrusion process. Okay, next the third type of extrusion process is the impact extrusion. Just like the indirect extrusion, here also the direction of the movement of the product and the applied force is opposite, but the nature of its working is a bit different. Here we will make use of a punch. This is the punch of the desired shape, and a die of the desired shape. The material which is to be deformed is placed on the die surface, and there is some clearance between the punch and the die. So if we closely look, that this is the clearance between the punch and the die. So when the punch makes a contact with the workpiece material, this is the workpiece, makes the workpiece blank, it compresses it, and the only space left by the workpiece to come out is this clearance between the die and the punch. This clearance between the die and the punch. So this is the actual representation of the die as I have shown here. This is the actual representation of the die. So the workpiece will come out through the space, to this clearance space, and it makes a shape like this, So this is the extruded product. Okay, so direction of extruded product is this, and the application of force is in this direction. So this type of extrusion is generally used to make the toothpaste tubes or structures like these thin shells. Okay, next we have the hydrostatic extrusion. So just like the impact extrusion was the extension or a type of or a similar way of the indirect extrusion, so this hydrostatic extrusion is like the direct extrusion. Means that if the direction of the application of the force is in this direction, in the same direction we will get the product, just like in case of the direct extrusion process, with a change that the billet in this case is compressed. With the help of some kind of fluid. So if we consider this as the billet, this as the billet, and this is the die, in place. So this is the extruded product, this is the billet, and this billet is in contact with a liquid, fluid. This is in contact with a fluid. So this is the fluid, this is some fluid, and this is our ram. So if I draw its front projection, this is the container, at one end of it we have the die installed, okay. Then we have the die backer to support it, to fix it. Then we have the required billet, this is the billet, and this billet then is in contact with some fluid. It is in contact with some fluid. It is filled with some fluid. Okay, and then we have the ram. Then we have the ram. This is the, for example, the pressing plate, and then we have the ram. This is the ram. So as the force is applied by this ram, as the force is applied by this ram, that force will get transferred to the different particles of the fluid, and those fluids are considered to be incompressible in nature, will transfer the whole of the force which is applied on it uniformly on the billet surface, due to which the billet will come out of the desired shape of the cavity, shape of the die as the extruded product. So here the workpiece, the billet is compressed with the help of the fluid, with the help of a fluid. Okay, so due to the presence of this fluid, which is considered to be incompressible in nature, so this helps in elimination of the friction forces which were in between the billet and the cylinder wall, with the help of the cylinder wall. And with the help of this hydrostatic extrusion, the slightly brittle materials may also be easily extruded. Okay, so which were is slightly difficult to extrude with the help of the direct extrusion process, because in these brittle materials some cracks may develop during the deformation in the direct extrusion process. Okay, so the materials which has the low ductility may also be extruded with the help of the hydrostatic extrusion process. So this is all about the different extrusion processes. Let us have a look on some videos where we can observe the actual happening of the extrusion process. So this is the first video. Here we can see that this is the die which is being placed with the help of a fixture. This is the die backing area container. This is the billet which is to be extruded. The shaped sized billet will be placed here, which will be compressed with the help of a ram. Firstly, some anti-sticking agent is applying. Now it is being compressed through this die, and an extruded product with the help of a chillers will get cooled, and we will get the desired length. Okay, so this is the extrusion process. We can have a look on the extrusion process in industry as well, how it works in the industry. So this is the ram, this is the billet, this is the container. It is being forced through this container with the help of this ram. We said ram will fed the billet and will compress it through the container and a die, and this is the extruded product. Okay, this is the ram. So the performance of this setup extrusion will depend on the friction between the billet and the container walls, and the material which is to be extruded. The friction between the billet length and the container and the material are the main two factors to define the performance of the extrusion. Okay, so initially, in order to deform it, we will need large forces. We can see that first this area will get filled, then when the extrusion will get start, the amount of forces required will get slightly reduced. To a point. Okay, so this is the extrusion process, and at the last stage, a thin disc and the material has to flow against the friction forces on the die surface and the pressure plate. So this is the extrusion process. We can have a look on the impact extrusion process as well, how the impact extrusion work. So this is the example of the extrusion work, where a thin blank or workpiece is forced through the clearance between the punch and the die. So this is the initial workpiece. At below we have, this is the die, this is the punch. So blank is fixed here, then punch compresses it, and through the clearance between the punch and the die, the tube shaped structure is formed here. Cup shaped structure is formed. This is the workpiece which is get which is getting in this in the opposite direction of the ram. So this is the impact extrusion. These are the small workpieces called as the blanks. Okay, this is the extrusion process, impact extrusion. Just have a look on the direction of the movement of the punch and direction of the workpiece. These are opposite. Here punch blank is placed, punch compresses it, and materials comes out in this direction. So this is the impact extrusion. So this is all about the extrusion process. Thank you.